Okay, so this video is going to cover how we draw a budget line. And so for a budget line, since football season is coming up, and maybe you go to Troy football games, and maybe we'll actually have some fans in attendance this year. We'll see. Who knows? Suppose you're going to go to a Troy football game, and there's two possible items you could buy. And so again, we're talking about consumption goods here. And so let's just say we have beer and hot dogs, and we know that at Veterans Stadium, beers are $5 and hot dogs are $4. And so this video only applies to you if you're old enough to actually buy beer. So if you have these prices for two goods, and these are the two goods you're going to want or you're going to be able to buy. Again, this is a consumer choice model where we simplify things down to a world in which we assume consumers are purchasing two goods. So we have two goods here, beer and hot dogs, and we have prices for them. Now, the other thing we need to have to make a budget constraint is that we have to assume somebody has a given amount of money. And we call it the person's income. That's probably it may not be the most accurate way to describe it. I think it's probably better to think about it as their budget. This is the amount of money that they've decided they have to spend in this period of time. Because this might be like, say, what you're going to buy at one football game. Well, income is, you're not working while you're at the football game. So, but your income is something you've earned at some other point in time. And somehow you've come to the decision, we know how much money that you have to spend. And that's going to be given. That's given. That's exogenously determined. If you remember the term exogenous variable, that's set here for the consumer. They have a given amount of money that they can buy, that they can spend, and the things that they want to buy are costly. And of course, most goods are going to be costly because they're scarce. Because they're scarce, it's going to require scarce resources or labor effort for somebody to make them, and then they're going to have to charge money for them. So you'll face a positive price for goods, and you have some given amount of money that you can spend. So at some point you're going to spend all your money. And what we have here is the budget line shows the different options a person could face given their income and their prices. The budget line is going to lay out all of those affordable choices a person could have. Then we're going to put the budget lines together within difference curves to show how the consumer is going to maximize their utility. So let's figure out here, how would we go about graphing the budget line in this case with this information? Well, the easiest thing to do is take whatever goods on the x-axis and do this thought experiment. What if the person spent all of their money on beer, the x-axis good, how many units of it could they buy? Well, income's $20, beer is $5 at the game. So that means that they could buy up to 4 units. I guess 4 beers at the game. So we count them out here. And we know that we would have a point on the budget line here. With we could afford 4 units of 4 beers and no hot dogs. The other thing we could do is ask, well, what would be the how many hot dogs could you buy if you spent all of your money on hot dogs? Well, the price of a hot dog is $4. Income's 20. 20 divided by 4 is going to give us 5. So we could trace that out here. And we'll have a point here because, again, if you're spending all of your money on hot dogs, then you don't have any money to spend on beer. So the quantity of beer you'd have in this bundle would be 0. So 0 and 5, 4 and 0, that gives us 2 points there. And then what we'll assume is a budget line is what we call a budget line. It's going to be linear. And we'll see in a second, because with the nature of the prices, this would end up being linear. So what we could do is, since 2 points can determine a line, we could take these 2 points here and draw a negatively sloped line between those 2 points, and this would then be the entire budget line for the person. any point that would be on the budget line is affordable. Any point that would be inside of the budget line would be affordable. So we'll write this down here. Any point that's outside or to the northeast of the budget line would be unaffordable. Now, one thing you might wonder here, this was also the case with indifference curves. We're assuming that people can have like fractional units of the good. For our purposes here in this model, we'll assume that fractional units of the good are a thing. Now, obviously, we don't actually have that in the real world, and it's actually mathematically make this problem a little more complicated. But you could say like, oh, if you buy 2 beers, that's $10. And then you only have $10 left over, you could only buy 2 hot dogs. You couldn't actually buy 2.5 hot dogs, which is really what we'd be assuming here when we draw the budget line. We'll just make our lives a little bit simple and assume that we've got a nice straight budget line, which means that we're letting this person buy fractional units of the good. All of these goods are infinitely divisible. So that's a little bit of a simplification. That is a simplification. It might seem like a problematic simplification because, you don't have it in the real world. But, economists, by assessing this, have determined we haven't really haven't really lost very much by doing it. We want to say that what we have here is a budget line. How can we make sure of that? Well, one way to write this out would be to say, suppose we wanted to figure out your expenditure. We could figure out how much it would cost you to purchase any bundle in this space by taking the prices, and then let's just, for convenience here, we'll let beer be good X since it's on the X-axis, and then hot dogs be Y, and since it's on the Y-axis. So what we would say is like, okay, X will be the number of units of the number of beers you buy, Y would be the number of hot dogs you buy. And we could just apply the prices here, and we'd say like expenditure of any given bundle in the consumption space would be 5 times the price of 5 times the number of units of beer you want to buy, plus 4 times the number of hot dogs you want to buy, and that would give us the total expenditure. Now, what we do for our budget line is we assume that a consumer has a fixed amount of money that they can spend. So we set that we set this expenditure amount equal to the budget lines, or the budget amount. And then that gives us the actual budget line. So it is a line because if you have it in this form, you could rewrite it easily to get it into slope-intercept form. And here we have 20 minus 5x. Well, to actually put it quite the way we have it before, we have a minus 5/4 x plus 20. So that's mx plus b. And we can see that as we saw just on the graph, the budget line is going to have a negative slope because if you're spending all your money, on hot dogs and you want to start to buy some beer, you have to buy fewer hot dogs. There's simply no way around it. The only way you can have some money to buy beer is you have to buy fewer hot dogs. So the budget line, when you're spending all your money, it's going to have a negative slope to it because to be able to afford to buy some beers, once you're spending all your money on hot dogs, you have to buy fewer hot dogs. So this is what the budget line is going to look like. It's going to have a negative slope. It is a line because when we put it in this fashion here, we can see that it turns out to have the form of a line, and it separates what's affordable from what's unaffordable. In terms of preferences, we know that people want lots of stuff. They want as much of these goods as they possibly can get. When we put a person's indifference curves on here, we're going to be able to maximize utility. Okay, so this is the budget line.